improbable that doing it by random, by chance, becomes. Secondly, improbable patterns must be independent. That means that whatever patterns we see, they can't be linked in some. Classic example. Suppose an archer takes and shoots 5 arrows into the side of a building. Then somebody goes over and paints bullseyes around each one of the arrows where they land. And then he claims, I make 5 bullseyes in a row. It's improbable that you would get 5 bullseyes in a row, but he's linked the patterns of the bullseye and the patterns of these arrows. So it's not an independent situation.
Right.
As opposed to if we painted 5 bullseyes first, and then he shot the arrows, every one of the 5 hit the middle of the target. Now those two events are not linked. And so we have to say there was some reason why he was able to do that task, or that pattern became in existence. Resources. Resources equal opportunities for occurrence. If you want to take and pull 4 aces out of a card of 52, or a deck of 52 cards, and so you shuffle the deck and you pull 4 cards, not an ace, and you shuffle it again, not aces, shuffle again. You keep doing it. You do that a dozen times, the probability that if you only do it 12 times, you're going to get 4 aces is pretty small. Now let's redo the experiment and let's shuffle and pull, shuffle and pull. Let's do it 1,000,000 times or 1,000,000,000 times. What's the probability that at some point you're going to pull 4 aces? Now it's finite. So the more resources we have for a probabilistic event, the more likely it is we're going to have that event. Okay, so specification applicable to patterns. Here, specification really defines that in a given pattern, we're looking at complexity that is neither totally random nor totally fixed, not completely predictable. So the probabilistic part of the specification applicable to patterns represents defining that boundary between total randomness, total chaos, and total predictability. So that has to be known. And finally, we have a universal probability bound. We have to be able to say something is so improbable that it can't happen. It's just unreasonable to believe that it happened. So that number has been calculated by mathematicians. Some people estimate it to be 1 in 50, some 1 in 150, 10 to the power of 50, 10 to the power of 150. Big numbers. Is this kind of approach, are these kinds of philosophies used anywhere besides in activities like we're doing now? The answer is yes. The SETI program, the Search for Extraterrestrial Intelligence, set up by Carl Sagan, has its tenets the specified complexity. So it looks for signals from outer space and it uses these tenets of specified complexity to say, this is a random signal, this signal has structure, has design, and intelligence behind it. It's probably coming from somebody broadcasting it. So that's how they determine if all these signals, they're monitoring, and they have people all over the world monitoring these things all the time. So he uses specified complexity to sort through all those signals. Next slide. Okay, what is irreducible complexity? Well, this is a term which was first proposed by Michael Behe of Yale University. It really states that a system or structure cannot retain its function if even one of its components are removed. He gave us an example, the Rube Goldberg machines. Now, some of you younger people may not know what a Rube Goldberg machine is. It was very popular as a cartoonist during the time of the Depression and for some years afterwards. But essentially, it's where he takes common household items and links them together in order to make a very simple task more complicated. For example, you want to pour a glass of water, and so a ball has to fall down over here and trip a teeter totter, which lights a candle, which burns a string, which does something else and tips the pitcher and fills their glass of water. Very complicated. But if you remove any one of those steps, the machine stops. It doesn't work anymore. We had a children's game that may have played called Mousetrap, worked on the same principle. You had to play the game and you put all these pieces into the chain. At the end of the game, you drop a marble, a steel ball or something, and it went down a basket and down some chutes, and you settle these things off, and eventually you trap the mouse. Same principle. If you remove one of those components, from that chain, the machine stops working. So that irreducible complexity then, as defined by Behe, addresses what's known as direct Darwinism or direct random evolution. That is, if you remove a piece, it stops. However, it doesn't address indirect. That is, suppose we remove a piece and we modify one that's still there to take over some of the functions that the removed piece had. Then that's indirect evolution, and that is not addressed by irreducible complexity, but it is by specified complexity and by an argument that says in any given machine, if it has a goal, then it has to have a certain minimal complexity. If you take too many pieces out, even if you modify some, you lose the minimal complexity. So as Dempsey says, there's no free lunch here. Still things have to maintain some amount of complexity. So, summary, what can we say? Well, one, critics of irreducible complexity often argue that biological and biological examples, biology and biological examples, biochemical and biological examples, are often formed in soft tissues, and we don't have a record of soft tissues. They're not the fossils. This is essentially an argument that says absence of evidence is not evidence of absence. That just because the fossil record or known biochemical processes don't show these simplified intermediate steps for each of the components doesn't mean that one may not exist. But Dembski points out that in biochemistry, the absence is pervasive and systematic, so that even critics of Darwinism like Frank Harrell and James Shapiro, neither of whom are supporters of intelligent design, by the way, state that positions of as yet undiscovered indirect Darwinian pathways constitute wishful speculation. So it's, again, an issue of saying, well, we don't find it, maybe something exists somewhere, but that's really speculation. So, despite its many centuries of successful application, its many proponents, both at the macro and the molecular level, intelligent design continues to be strongly criticized by biologists and biochemists who have some vested interest in maintaining their humanistic roots of their science. For us, and for myself, intelligent design, when we can show it, simply implies that there's an intelligence in the world around us, and if there's an intelligence built into the things that we have in the world, then that implies design. We pointed out that many of the things that we run into in the world appear to have come into existence, been in existence for some long period of time, and have gone out of existence with no particular reason. Okay, to try to guess what the reasons are, it's beyond the scope of intelligent design. However, when we look at the scriptures that we read, it clearly states that man has a special role to use his resources wisely. So if we look at the facility we're in today, the fact that we have lights on overhead, that we have air that's cooling us and keeping us comfortable or warming us depending on the weather outside, it says we have learned to use our resources, and many of those resources were created during the times of this geologic periods in which man was not functioning on the earth. So that, in essence, says somehow parts of our creation were designed so that we would have what we need today. Okay. Brett?
Thank you.
Amen.